On the heating curve, there are two plateaus. One's here, where ice is melting or water's freezing, and then there's one up here, where water is boiling or water is condensing. At these points, if you add more heat to the solution, instead of the heat raising the temperature of the substance, that heat energy goes to doing one of the following. If the object is melting, the energy put in is used to change the substance from a solid to a liquid. So if you have an ice cube and you are at 0 degrees Celsius, so you're right here, any extra energy that you put into it is going to cause that ice cube to melt. The energy required to change an object from a solid to a liquid is called the heat of fusion. So melting it, heat of fusion. The opposite is also true. If an object is freezing, all of the energy that the object is losing results in the change from liquid to solid instead of a decrease in temperature. And that's why it says both things here. So if you're giving it energy, the ice cube is melting, so it's going from solid to liquid. And then if it's losing energy, you're going from a liquid to a solid. But the temperature still stays the same while that process is happening. It's staying at 0 degrees Celsius. For either freezing or melting, it's called the heat of fusion. It is a constant for each substance, and for water, here are some numbers. First of all, here's what it is. Delta HF is the heat of fusion, and then these are the constants for water. 333 joules per gram or 6.02 kilojoules per mole. It just depends on what unit you want to use, and some questions will talk about it in grams, some moles. So here are both of them. For either vaporization or condensation, so now we're talking about up here. Vaporization is when you go from liquid to vapor, all right, so that's gaining energy. And then condensation, that's when you go from vapor to liquid, and that's losing energy. Same thing is true here. So we have the heat of vaporization, or delta HV, and then these are the values for water. So it's 2,256 joules per gram, or in kilojoules per mole, it's 40.8. As you can see with the numbers, it takes a lot more energy to change something from a liquid to a vapor than it does to go from a solid to a liquid. In other words, melting ice takes less energy than boiling water. And let's look at the numbers. So this was for melting, 333 joules per gram. So if you had 1 gram, it would take 333 joules to melt that 1 gram of water, to go from an ice cube to liquid water. Now, if you still had that 1 gram and you had now water at 100 degrees, it would take 2,256 joules to go from liquid water at 100 degrees to water vapor at 100 degrees. It would take 2,000 joules. So it takes a lot more energy to boil things. One last interesting fact is that the freezing point and the melting point of water is both exactly 0 degrees Celsius. It's exactly the same. How can they be the same? Well, if water's losing energy, then it's freezing. And if it's gaining energy, then it's melting. They don't just stay at 0, though. It's either going from lower than 0 to above 0, or the opposite is true. It's going from above 0 and then down to below 0. So it either has to be losing or gaining energy.